I'll now introduce the Murray Innovation Lecturers. At this time, please welcome Phillips Baker Jr. Phil has been the CEO for almost 20 years, starting with the company when the price of silver was at its lowest in the last 30 years. As a company with a long history, Hecla faced significant legacy environmental liabilities, which Phil successfully resolved with hundreds of millions of dollars of expenditures long before the rise of ESG. By selling Hecla's mines in Venezuela, where the company was the country's largest gold producer, he used the proceeds to increase Hecla's ownership of one of the world's best silver mines, Greens Creek, to 100%. He has encouraged the development of a new mining method at the long-lived Lucky Friday mine, which makes the next 20 years of the mine safer and more productive. He's a leading voice for the importance of silver as a metal necessary for renewable energy. Please welcome Phil.
It's a little bit complicated the way they have this set up. Today, thanks in part to the Underhand Closed Bench method of mining at the Lucky Friday, we're producing more than 4 million ounces of silver a year. But in 2001, when I arrived at Hecla, the future of the mine was uncertain. At the time, the price of silver was $4.10. And the cost of production without considering capital was $5.50. Some believe that the Lucky Friday should be shut down and allowed to flood, a step that at best would have closed the mine for a very long time, at worst would have ended the opportunity to mine there forever. But others recognized the potential, and I saw that the Lucky Friday was Hecla's second largest resource, one that had 10 more years of production. And silver deposits of size are a rare commodity. And today, the Lucky Friday is the 12th largest reserve in the world of a primary silver mine. Because silver resources are so hard to find, to develop, and operate, I was convinced that we needed to try to keep the mine open. Since then, we've worked hard not just to keep it open, but to make it safer and more productive. Remarkably, since 2001, the Lucky Friday mine has produced 50 million ounces of silver, and based on what we know today, there's at least 100 million ounces more left to be mined. And innovations like the Underhand Closed Bench method don't happen by accident, and we're going to explain to you what this method is, and it's all about innovation. But they're a result of a long-term mindset, the commitment of skilled and experienced team, a willingness to make the most of opportunities and challenges, and a relentless drive to improve. And that's what saved the Lucky Friday back in 2001, and it's what defines the culture of our 132-year-old company. Now, we're really honored to receive the Robert E. Murray Innovation Award. I knew Bob Murray personally, and I believe that he would be really pleased that the Underhand Closed Bench method is at its core not just about increasing production. In fact, it wasn't about increasing production. It was about protecting the miner. Now, I'm going to be joined today by Chris Neville, the operations manager at the Lucky Friday, and Chris is the guy that has been instrumental in the Lucky Friday's history to deal with the challenges of seismicity. He's been there seeing the need for change in the way we mine. He worked on the idea of developing a continuous miner. And then he's part of the team that recognized that a new way of mining was really better that we didn't expect. And in a few minutes, Chris will do a great job of describing to you the method and the way, the challenges that we had. So what I'm going to do is provide some background to the Underhand Closed Bench method, a bit of history, I'm going to recognize lots of employees, consultants, and organizations that were part of developing it and putting it into practice. Now, we are going to use some acronyms, so I thought maybe I should define them. The first is Underhand Closed Bench, and you'll hear us call it UCB. The second is Remote Vein Miner, and this is a continuous mining machine that we developed with Epiroc. We still have it. We just have not implemented it, and the acronym for that is RVM. And then LUFL, the Lucky Friday underhand longwall method of mining, which is one that we invented in the 1980s, and that's what we're going to replace with the UCB. So Hecla is the United States and Canada's oldest precious metals mining company, which tells you we've seen a lot of change in both mining industry and the world over those 132 years. But we've had an unfailing commitment to our long-term vision. And for us, it's been that we would acquire and invest in long-lived assets that allow us to learn the geology, learn the ways to mine it, to build on the existing capital to generate high returns, and build strong-term ties with the local community. And today, those operating mines include 3 primary silver mines: the Lucky Friday, of course, which is in Idaho, Greens Creek in Alaska, Keno Hill, that's in the Yukon, as well as a gold mine in Quebec, Casa Berardi. And then we have more than 6 different exploration or development projects in our portfolio that are consistent with our strategy. Now, back in 1891, when Patsy Clark, Mace Campbell, John Finch founded Hecla, they made a key decision, not too long after that, to hire James McCarthy as the CEO. Now, he was a mining engineer that continually brought new ways of operating to the company, and during his tenure, Hecla led the way in electrification. So I was surprised when I was visiting the Ford Museum in Dearborn to see Hecla's 1903, the transmission line for Hecla's 1903 100 horsepower hoist engine that came in during the McCarthy era. And McCarthy was the CEO for 27 years, and his commitment to innovation, I really think, started Hecla on this path of being committed to innovation. And so over the years, Hecla's developed deep shafts and new equipment of every type. And one of the unique features of Hecla is the long tenure of its employees and of its CEOs. And I actually think that's a critical element to having a long-term mindset and a culture of innovation. So my predecessor, Art Brown, he was CEO for 16 years. I'm only the 11th CEO in our 132-year history, and so nearly half of Hecla's existence has been with just 3 CEOs. And it's not just our leadership that's committed to longevity. We have countless employees who have served the company for years, providing skills, experience, and expertise that's critical to our success. And although we're focusing today on the Lucky Friday, our people continuously drive innovation at all of our properties. So at Casa Berardi, we have an automated haulage system with trucks that drive autonomously underground 1.5 kilometers, goes to a hoist that automatically takes the material to the surface. And so as a result, work that would have taken 4 or 5 people per shift is now done by 1 person. And at our previously operating San Sebastian mine, we used an ore sorter to add to production. It was a very, very successful project. And at Greens Creek, we've implemented automated drilling to improve mine performance and reduce the amount of over and under break, so we have less dilution and less waste to haul. All of these innovations were possible because Hecla has fostered a company culture that values continuous learning, remains open to ideas, and is willing to adapt change. What we have discovered is that some of the best ideas are often years in the making, and as we talk about this UCB, you'll understand why we say that. So we appreciate both the successes and failures in the learning process, and you'll also see successes and failures. So we know you have to try things out and you have to be willing to fail. Now I'm going to spend a few minutes and a few slides really laying the groundwork. And this slide I think is pretty important because it really does sort of lay out kind of a timeline that helps you understand the journey that Hecla has been on. And so Chris will come in, and you'll see on this slide the 2017. That's really where he's going to start the story of what was happening in the mine and how we got to the UCB. So when we're telling the UCB story, it's really hard to know when to begin. And this slide starts in 1980, but I'm actually going to go a little bit further back on more than one occasion in just a moment. But I'm going to start the timeline with a gentleman, Wilson Blake. And back in the 1970s, he was studying seismicity at the Galena mine in the Silver Valley when he was earning his PhD. And in those days, Bill Anderson was the general manager of the Star Mine, and that mine eventually played an important role with where we find ourselves today. I think that mine shut down in 1982 to give you a sense of the history of things, the importance of building on those that came before us. My predecessor, Art Brown, was also central in the story at that time because everything that happened at the Lucky Friday in the late 70s and 80s were at his direction. So in the late 70s, the Bureau of Mines put out a request for a study on how to control rock bursts in the Silver Valley. While the Bureau would fund the research, industry had to actually implement it. So Wilson Blake and a young engineer named Mark Board, who is very much central to this story, looked at work in the Sudbury and proposed a new mining method to control seismicity. And around 1979, 1980, Mark approached several mining companies in the Silver Valley to do some basic research, including Asarco's Galena, the Sunshine Mine, the Lucky Friday, and the Star Mine. And Bill Anderson, the GM at the Star, was the only one to agree to support the research. And they began testing a method that Wilson called preconditioning the rock. Interestingly, this work at the Star has really led to two new mining methods, the Luffel method that we implemented in the 80s and now the UCB method. Going back in time, even before this, 1958 is when Hecla acquired the Lucky Friday mine, and we bought it. We bought the whole thing in '64, which, by the way, Newmont was instrumental in that happening, as it turns out. It's a whole other story that I could certainly tell you. And the Lucky Friday then constructed the number 2 shaft, which was commissioned in 1960, and that shaft allowed access to the Lucky Friday with conventional mining. But then we built the silver shaft, which was a mile below the surface. And this is really fundamental because what this 1 mile deep circular concrete lined shaft did was allow for a number of innovations. The shaft itself, there was a lot of uncertainty as to whether that shaft would be able to withstand the pressures of the Silver Valley geology. Paste backfill, rubber tired equipment, and this new mining method, the Lucky Friday underhand longwall, or the Luffel method. And that method was a significant adaptation of those early trials at the Star. And the engineer who led these efforts for Hecla was a guy by the name of Fred Brackenbush. Many of you probably know Fred. Another engineer, George Sturgis, who worked for the contractor on the silver shaft, was the principal leader of the Lucky Friday 4 shaft, and this shaft, almost 2 miles below the surface, gives access to the Lucky Friday's deep, highly stressed ore. In 1998, Hecla began mining the Gold Hunter vein at the Lucky Friday, and this vein outcrops about 8,000 feet at the surface. By 2001, when I started to work at Hecla, all of our mining at the Lucky Friday was on the Gold Hunter vein. And by the way, 2 years after that is actually when I met Chris To give you a sense of his involvement with the Lucky Friday, he was on the 5900 development. He was the engineer that was responsible for managing that. Now, the Luffel method worked reasonably well for the next 15 years. And since the Gold Hunter is a weak argillite vein that squeezes rather than bursts, however, the vein has the complications of more faults that risk slipping without warning. And the Lucky Friday presents a huge number of challenges. First, the mine's very deep. It is, in fact, the deepest mine in the United States. Only 2 mines in North America are deeper. Second, it's extremely hot. At the bottom of the mine, the ambient rock temperature is 155 degrees. Third, the mine is well known to be seismically active. I was in China a number of years ago, and this Chinese mining engineer said, "Oh yeah, I know about the Lucky Friday. I studied it at my Chinese university." The seismicity has changed from rock bursts in the Lucky Friday vein to these fault slips in the Gold Hunter vein, but both create safety risks and reduce the mine's productivity. And when the mine was at full production toward the end of this period, using the Luffel method, about 25% of the time we had to shut down certain stopes a shift or two to safely allow for the seismic activity to occur. Another challenge were the work rules, the Lucky Friday, and these were rules with the union workforce. What these rules allowed senior miners to do was determine where they worked, who they worked with, and inevitably what would happen is the experienced miners would end up working the easiest, most profitable stopes. That meant we had to mine more slowly in some stopes, which generated poor geometries and led to greater seismic potential. And about 8 years ago, Lucky Friday had a seismic event that emphasized the need for a new mining method. We knew that as we mined, our activity would put stresses on the rock that would eventually cause those faults to slip. So Hecla had to look at ways to reduce the stresses around the stopes. We knew that a day or so after we created the excavation by blasting, the area becomes inactive. With no mining, little seismicity. So we concluded that if we preconditioned the ore in advance of the stopes using larger blasts, not only could we physically mine out troublesome faults near the stope and prevent them from slipping, but we could also redistribute stresses into stable, confined rock far in advance of the stope. The result would be to reduce the energy that's released during mining and control the stresses that are applied to the faults where people are working. So then the next question was, how do we best safely mine the heavily preconditioned rock in advance of the stope? So that's where Hecla took a huge leap. You could say that we even hoped to find a holy grail of mining, a way to cut the preconditioned rock productively while removing the miner from the face, eliminating all of the safety risk. So we decided to develop a mechanical mining machine, the remote vein miner, that could rapidly cut the rock. Fortunately, Hecla had hired Claire Alexander a couple of years earlier, and he had already led a team at Rio Tinto that had developed a rock cutting machine at Atlas Copco. I've been asked how we got the company to move forward with the RVM, and frankly, it was a balancing act between believing it can work and believing that even if it didn't, we would learn. And we knew we had to innovate. We knew the issues of the Lucky Friday. So on several occasions, I would compare RVM to exploration. Most work associated with exploration isn't successful, but it's still a necessary part of reaching a successful outcome, and the RVM was no different. On occasion, I would tell our team that the RVM probably was not going to work. Yeah, that did not go over well. But that was okay because we were going to learn, and in fact, it's very approach to learning that led the RVM to a solution that was even better. And here's where I need to share a key element to the story, and that's the support of Hecla's board. You can't do this without the board buying into it. And our board has a mindset of innovation. They understand the need to change the way we mine. And so consider this, in 2012, 2016, 2021, our board actually had board meetings on the floor of the MINEXPO convention. And we would go from vendor to vendor, looking at equipment that we were considering, looking at equipment that we had in our budget, and going through that with our board. And just new ideas. And I can tell you, we bought things and we've operated things that we've ended up not going forward with. But it's all part of the process. Ultimately, Hecla chose the UCB method over the RVM. And the way I saw it was the RVM was a single point of failure. A failure of that machine would stop production. And as the first continuous miner in this sort of hard rock, narrow vein environment, it was going to take time to make it consistent. With the UCB method, on the other hand, I could see several advantages. The Lucky Friday already had experienced success with the method in a limited way, as Chris will go through. And theoretically, production from the UCB should far outstrip the hoisting and milling capacity of the mine. And finally, the transition from the Luffel to the UCB would be faster and more straightforward than the transition to the continuous miner. Remarkably, 2 unexpected events brought us more time to research and explore the options before making our decision. When the union went on strike at the Lucky Friday in 2017, it gave us extra time without the pressures of ongoing production. Workers didn't return until 2020, which of course is when the world was hit with COVID-19 pandemic, and it gave us time and space to do the preconditioning blast that Chris will talk about in a moment. And in the end, the COVID supply chain issues prevented us from shipping the RVM to the Lucky Friday. That reduced the pressure to get the RVM going. And here's where the story gets more interesting. Earlier I mentioned the union miners would take the stopes they could easily mine, leaving difficult to the younger, less experienced miners. During the strike, of course, our engineers developed the new mining method. After the strike, older, experienced JIPO miners retired, leaving the Lucky Friday with a brand new method and a very young, inexperienced crew to implement it. Still, the accident rate dropped from what it had been with the experienced miners, and it dropped dramatically as a result of this new method. Now, the UCB method, the mine has gone from miner control to engineer and management control. We've shifted to task-based mining, where management decides how the mining is done. I'm convinced that without the strike, the UCB method wouldn't have happened. The work rules would have prevented the very experimentation that was needed to make it successful. But with the UCB method, the management of the Lucky Friday has created a much safer, more productive mine. As we explored this new method, we're grateful for the support of a number of organizations. Orica provided blasting technology with Icon detonators that assured the timing and consistency of the detonation. So if you look back on that slide I showed you earlier, you would have seen when this came into existence, the importance of that innovation. ESG improved seismic monitoring. Northwest Energy Service supplied the product, and Bort Longyear provided the long-hole drilling. So now I'm going to turn the floor over to Chris, who will talk about the UCB.
Thank you, Phil. As you said, I'm the operations manager at the Lucky Friday, and I grew up in Mullen, Idaho, where the mine's located. At that time, I was 15 years old, and I could sit in school, and I remember the rock burst that occurred from Lucky Friday. At that time, there was no cell phones, and the notification for the ambulance crew to mobilize was a loud siren that you could hear all throughout the town. It was all too common that shortly after the windows rattle in the school, the siren would sound, and the ambulance would be at the Lucky Friday mine. I have to give you that perspective so you understand exactly how excited I am about the achievement the UCB has done at the Lucky Friday. I'd like to give you a little bit of background about the Lucky Friday. The diagram that you see here, the silver shaft is the main access to the mine, 6,100 foot deep, and it was initially used to mine the Lucky Friday vein. The 3,700-foot deep forest shaft sits about a mile to the northwest and is used to access the Gold Hunter veins down to the 8,300-foot level. The bottom of that shaft is nearly 10,000 feet below the surface. We've had 3 generations of mining in the Lucky Friday. Initially, we used overhand cut and fill in the Lucky Friday vein down to the 5,100-foot level. Then in 1985, as Phil discussed, the Lucky Friday underhand longwall was invented to mitigate pillar rock bursting that was experienced because of the overhand. This greatly improved safety at the mine. And now for the past 3 years, we've successfully used the UCB method, which further mitigated structural seismicity at the mine. The Lucky Friday is well known for its seismic challenges, and this graph made by Gabe Walton from the Colorado School of Mines demonstrates just how challenging it is. You notice the Lucky Friday has the highest stress concentration than other seismically active mines in South Africa at half the depth. The Lucky Friday has a major horizontal stress that's about 1.5 times the vertical stress. It has multiple numerous faults that are prone to unstable slip. And you combine this with the mining of a narrow, near vertical tabular ore body. This combines to have some pretty significant seismicity. Now there's multiple ways to manage that seismicity. There's obviously monitoring, exclusion protocols where you keep the miners out of the stopes. There's extraction rate. There's geometry such as mining underhand and not creating pillars. And of course, the use of dynamic ground support. What this story is about today is de-stressing and preconditioning and how we use it to develop a new mining method. This seismic event that you see here that caused the damage is the reality of our concerns. In 2017, we had a 2.15 moment magnitude event occur in 15 stope caused by a floor wedge that was bounded by 2 faults that cut across the stope floor. That event caused 5 to 9 feet of floor heave for 80 feet in the stope. It's this type of event that drove us to continue to find a better way to mine. In 2019, de-stressing and preconditioning that Phil talked about came to the forefront again, and this was the actual catalyst that kicked off development of the UCB mining method. The diagram you see in the upper right shows the underhand 12 stope that's lagging behind 15 stope by about 90 vertical feet, and it created this corner geometry that caused a stress concentration that was just a seismic problem for us. So we developed a de-stressing pattern of tightly spaced 4-inch holes drilled 60 foot deep that was intended to crush that zone so it could not carry any energy. At the same time, 15 stope continued to have seismicity problems and floor heaves, so we developed a preconditioning pattern there of widely spaced 4-inch holes. And I'd like to define a little bit difference between those two. The preconditioning was intended just to interrupt the fault below the floor, not totally crush it, so it wouldn't carry as much energy. Whereas the de-stressing was intended to just crush the zone completely so it had no capability to carry any energy. The picture you see on the left is a swell muck with the large boulders in it after the de-stress blast. When we saw that, it was like light bulbs flashed, bells rang, and we asked ourselves, many of us, what if we just put a few more holes in that and broke the rock a little finer?
Hecla Mining Company has pioneered underhand closed bench mining, a patent-pending method that controls the release of seismic energy, improving safety and productivity in the deep, narrow vein mining front. Here's how it works at our Lucky Friday mine in Idaho. UCB blasts a longer, deeper area of the stope, releasing seismic energy during blasting when personnel are out of the mine, allowing miners an accelerated, safer, and more efficient way to remove fuel. UCB blast hole rings are drilled to break 24 feet deep along 250 feet of the stope floor. Using 25,000 pounds of explosives, we blast 10,000 tons of rock at once, rapidly fragmenting the ore below the floor. The traditional cut and fill method releases seismic energy incrementally over 10 weeks, the duration of mining in 2 cuts. UCB releases over 90% of the total seismic energy around the stope within 12 hours, 1 work shift. UCB creates 100 times more fragmented ore versus the traditional method and de-stresses the mining zone, so there's very low risk of further seismicity. With the ore already fragmented by the larger blast, clearing the rest requires little to no additional blasting. We safely muck out the swell in 2 12-foot cut layers, backfilling the stope with cemented paste. Once we're back to a solid, unblasted floor, the UCB process is ready to repeat. Hecla has used UCB since 2020 with amazing results, giving Lucky Friday the best safety record in its history, while increasing production by 150%. UCB mining is the start of a new chapter in a long story of innovation at Hecla, one that goes back more than 130 years. We look forward to what's ahead.
So that video truly explains a significant change. The UCB was a major shift in how we mined at the Lucky Friday. As you can see, this is the change that occurred. You see the solid rock face in the picture on the left. That was the cut and fill face that we used to mine. If you notice, if you look close, you can see horizontal stress fractures in that face from when we mined the cut above of the stresses being redistributed down below, causing the fractures to occur. That's the seismicity. We went from that to drilling vertical benches, blasting, creating swell muck of finely broken rock that you see in the middle, to the picture on the right of what we eventually had of advancing faces just through finely broken rock. There's 2 key factors that really make this method successful. First, seismicity is managed, improving safety and productivity by eliminating almost all seismic delays. You heard Phil mention that 25% of the time a stope was shut down. With this, there's no seismic delays. Second, we are no longer limited to the end-of-shift blasting constrained by that solid rock face. With that broken rock, the miner can be productive throughout the shift. This chart truly explains, as the video showed, the benefit this method has brought to us. The bar on the left represents all the energy that's released in the mine in 1 quarter. That middle bar is that 90% of the energy is released within 12 hours of that blast, just opposite of what we're experiencing with the Luffle. The diagram on the right plots all of the seismic events that occur within 48 hours of a UCB blast, marked by hour. The color in red immediately below the UCB was within that 12-hour window. One unique thing about this method is the energy release per ton of ore mined is almost half of what the Lucky Friday method used to be. And this is mainly because when we blast, we cut through those faults, and it doesn't allow that fault to build up and store the energy and have an event like you saw in that previous slide in 2017. And I'd like to point out that this, as you can see, we have not eliminated seismicity whatsoever. It still occurs. We simply are dictating when that seismicity happens, giving the miner a safe environment to work in. And another notable aspect about this method, we have not experienced any seismic damage at the active mining front since we have actually converted to this, which is amazing. There was definitely some challenges with developing this mining method. First is we had to make sure that we drilled where the ore was. Our diamond drilling was on the 150-foot centers, and that was not adequate to project the ores. So we put a diamond drilling campaign into effect, reducing that to 50-foot centers, and you can see the change in the ore body. It went from the blue projection to the red. Absolute must to know where the ore is. Another challenge we had was just breaking the rock to the depth that we wanted. The one aspect I want to definitely mention here is electronic detonators, the icon detonators. Those made this method possible. Without those, we would not have the confidence that that powder column fully initiated. The icon detonators gives us that confidence so we know we can actually execute this method successfully. And I'll let you read everything else that's up there on the screen of what we've done. What I really want to emphasize here is that we failed. I don't know how many times we failed. We failed a lot. And as Phil said, we were allowed to fail. And we failed fast. At one point, we had 3 different styles of blast patterns and timing patterns in one stope, just so we could figure out how to make this happen faster. And we eventually did figure it out. And I can tell you, with the heavy ore that we have and this choke style of blast, we use a lot of explosives. The powder factor is extremely high. And we knew we figured it out because once we got it to break the rock, our closure in the stope went from 2 inches up to 7, 8, 9+ inches of closure immediately after that UCB blast. It was very impressive. That's what normally would have taken 10 to 12 weeks mining cut and fill. That closure prevented another problem of crushing the backfill overhead. We had embedded 6-foot bolts in the backfill on 4-foot centers, and that just wasn't enough. We switched to simply 8-foot bolts on 3-foot centers, reinforced that with a 0-gauge strap on the bottom, and that protected the miners from that fill totally crushing and falling out. Very effective. One other challenge was the paste wanting to saturate that broken muck that we just made underneath us. And again, just like the blasting, we failed. And I'll say we failed fast, because there was, again, another time we did 3 different methods of testing on how we would make this work. And what we eventually found out, a simple layer of 12-inch broken ore on the floor, compacted, was an effective barrier to keep the paste out of the muck. The safety improvement with seismicity alone makes this just a remarkable mining method. However, as Mark Board stated to me once, rarely, if ever, does seismic management around safety increase production. However, that's exactly what this method has done. From 2016 to 2022, we've seen a 68% increase in production in our lower 30 vein stopes. And in 2017, we're expecting another 2023, we're expecting another 17% increase in production. This is truly amazing between the safety and the production we've achieved. I think I hit that. There we go. The UCB invention, I have to say, is a testament to Hecla's dedication to continuous improvement and innovation. We definitely stand on the shoulders of many predecessors, beginning with those who tested de-stressing at the Star Mine in the late 70s and 80s. At the Lucky Friday, the circular concrete shaft, the first in the district that was a challenge, positioned Lucky Friday for the long haul to be successful. Through the years of using the Luffle mining method and continued de-stressing practices, as well as recognizing the need to change work practices in 2017, that's what it took to change to make this method. With the UCB, we're positioned to safely now produce 5+ million ounces annually, and the Lucky Friday is going to see some of the best years it's ever had. Thank you. I'll hand it back over to Phil.
So before Chris started his presentation, I mentioned some of the organizations that supported our innovation at the Lucky Friday, and now I want to recognize additional people within Hecla who made it happen. First is a group of now retired employees. Larry Radford was our chief operating officer, and he really recognized the importance of finding another way to mine at the Lucky Friday. And part of Larry's effort was to hire Mark Board, who was our Vice President of Technical Services. Mark is a world-renowned expert in rock mechanics. He told me I couldn't say these things, but and he is in demand all over the world. He's asked to deal with just the most difficult rock mechanics issues, and he became our technical services VP and came to Hecla because he knew the challenges that we were facing at the Lucky Friday. And he also knew that Hecla had the culture that could test and implement changes and do that quickly. And then Larry also hired Claire Alexander, who I mentioned had that practical experience with the continuous miner. And that was an important part of the process, was to look at doing it that way and then coming to the conclusion that there was another way of going forward. And then we have Wes Johnson, who's going to be giving a presentation in the technical session, so I would encourage you to attend that session to really learn in more detail what the UCB method is all about. He's an engineer that has worked on all aspects of both the RVM and UCB method. And then Matthew Armitage, he's a soon-to-be PhD who's done the modeling research and really has led on the rock mechanics issues, particularly since Mark's retirement. We have Carlos Aguiar, who's the general manager of the Lucky Friday, who has managed the shift from implementation of the RVM to changing to the UCB. And then we also have our Chief Operating Officer, Lauren Roberts, who came to Hecla about 3 months before that fateful blast that opened our eyes to the UCB method. There are more members of the team at the Lucky Friday, both technical and operating, that all played a significant role. And then there's finally the miners themselves that were instrumental in the implementation of this innovation. I can tell you, when I would tour the mine, getting a little Kubota, and I would have Byron, the foreman, who's a mountain of a man, and he would be there, this is during the implementation, he would be there lobbying me for the new equipment that they needed in order to really implement the UCB method. The miners were enthusiastic, and that's really part of what helped ensure the success of this new method.